Welcome back to the Deep Dive. It is Thursday, February 5th, 2026. And I have to say, looking at the stack of research we have for today, I feel like we're living in a timeline that was, written by a sci-fi author about 30 years ago.
It does have that feeling, doesn't it? Like we've sort of turned a page in history without really noticing the page number changed.
Exactly. We're digging into this piece titled Netizen, Low Earth Orbit, Not Moon or Mars, which just dropped today. And, usually when we talk about space, the conversation goes one of two ways. It's either look at that beautiful nebula, which is pure science, or it's when are we moving to Mars, which is, well, it's pure escapism.
Right. The whole lifeboat Earth narrative. We need a plan B.
But this source material is doing something completely different. It starts with this incredibly bold claim about an impending age of abundance that was prophesied in scriptures thousands of years ago, which honestly, when I first read that first paragraph, I thought, uh-oh, where's this going? Are we getting into theology?
I had the same reaction. It opens with a very high-minded, almost mystical hook. It's a bit of a curveball.
But then, and this is the whiplash, it immediately pivots to something incredibly concrete. It references this massive interview that apparently just happened with Dwarkesh Patel, Patrick Collison, and Elon Musk. And they're not talking about scripture. They're talking about orbital mechanics, data centers, and the business plan for XAI.
And that interview is really the anchor for this whole discussion. It's a snapshot of where the smartest capital in the world, where it's actually flowing. And the core argument of the source material today is going to upset a lot of people who have posters of the red planet on their walls.
I have a poster of the red planet on my wall.
Well, you might want to take it down after this hour, because the source is arguing that the public obsession with Mars, the colonies, the terraforming, the Plan B, is fundamentally a distraction. It calls them theatrical fantasies.
Theatrical fantasies. That is not a kind phrase.
It's not. But the thesis is that while we are all distracted by the theater of Mars, the real revolution, the thing that actually changes the human condition in the global economy, is happening much, much closer to home. It's happening in LEO.
Low Earth orbit.
Correct. The orbital city, as the author calls it. So our mission today is to completely reframe how you look at the sky. We're going to unpack why this author thinks Mars is a trap, actually, a sunk-cost mausoleum, to quote them directly.
Ouch.
Yeah.
Okay, we'll definitely get to that.
We're going to look at the flywheel of SpaceX, which most people, I think, misunderstand. We're going to get into the gritty, high-stakes geopolitical chess match between India and China that is happening right now, 500 kilometers up. And we're going to talk about why the next supercomputer you use might actually be floating in a vacuum.
It's a massive agenda. But I want to start with that theatrical fantasy idea because, look, I grew up watching Star Trek. I watched the moon landings, well, the replays. There's something deeply emotional about the idea of the frontier. We view space as the next Wild West. We go there, we plant a flag, we build a cabin. Why is the author so dismissive of that?
It comes down to utility versus romanticism. The source argues that we have conflated exploration with industrialization.
Yeah.
When you think of the frontier, think of the American West in the 1800s. People went there to live, yes.
Yeah.
But they also went there because there were resources that could be extracted and sold back to the east.
For gold, fur, land, timber.
Exactly. There was an economic loop. There was a business case. The author's point is that Mars doesn't have an economic loop. It's a destination, sure, a monumental one. But currently, it's a destination where value goes to die.
So it's a one-way trip for capital.
It's a one-way trip for capital. Contrast that with Leo. Leo isn't a frontier town anymore. It's becoming a metropolis. It's becoming the industrial park of Earth.
Okay, let's define the territory here, just so everyone is on the same page. When we say Leo, what are we actually talking about? Because to most people, space is just up. It's all the same.
Not at all. In terms of physics and economics, Leo and deep space are two completely different universes. Leo is defined as that thin shell, roughly 160 kilometers to about 2,000 kilometers above the surface.
160 kilometers? I mean, I drive that far to visit my in-laws. It's really not that far.
It's terrifyingly close. If you could drive your car straight up at highway speeds, you'd be in Leo in under 2 hours. You'd be there before you got hungry for lunch.
That puts it in perspective. That feels like a suburb, not another continent.
And that proximity is everything. The source calls it the logistics of proximity. And to understand this, you have to think about feedback loops. In engineering and in business, the speed of your feedback loop determines how fast you can innovate. The faster you can see what works and what doesn't, the faster you improve.
Right, the OODA loop. Observe, orient, decide, act. The military uses it, startups use it.
Precisely. Now, let's run an Odo loop for Mars. You launch a mission. It takes 6 to 9 months, best case, just to get there.
And that's only during a specific launch window that opens up every 2 years or so.
Exactly. So the timing is already constrained. Then you land. If something breaks, you can't send a technician. You can't send a spare part, at least not for another 2 years when the launch windows align again. The feedback loop is measured in years. That is agonizingly slow for technological progress.
It's like trying to debug code, but every time you hit compile, you have to wait 3 years to see the error message. It's an impossible way to work.
That is a perfect analogy. You just can't iterate. Now look at LEO. You launch a satellite, it's in orbit in minutes. If it glitches, you can sometimes fix it from the ground because the signal latency is just milliseconds, not 20 minutes. You can upload a software patch almost instantly.
And if it's a hardware problem, a solar panel doesn't deploy or something.
If it's physically broken, you launch a replacement next week. Or, in the near future, you send up a service tug, a little robot mechanic, to go fix it. The feedback loop is hours or days. You can learn, adapt, and redeploy at the speed of business, not at the speed of celestial mechanics.
So you can iterate, you can fail, learn from it, and try again quickly and cheaply.
You can iterate, and that's why LEO is winning the economic race. The source calls Ely a bustling global metropolis under construction. It's messy, it's crowded, it's getting dangerous, but it's alive with activity. Mars, in contrast, is described as a distant frontier town or a nostalgic campsite. It's quiet, it's pristine, and it's economically dead.
This brings us to the economic argument, which the source labels capital efficiency. I feel like efficiency is a really boring word for something involving rockets, but break it down. Why do investors, the people actually writing the checks, care so deeply about this distinction between ELO and Mars?
Because investors like money that moves. They need to see a return on their capital. They hate money that just sits still. The source explains that assets in LEO satellites circulate capital. You spend, say, $100 million to build and launch a satellite. It gets to LEO, it turns on, boom, it's generating revenue immediately.
Okay, so someone is paying for that broadband service. A government is paying for that Earth observation data. A shipping company is paying for that PNT signal.
Right. It's an asset with cash flow. You can depreciate it on your taxes. You can insure it against failure. It's a normal business object that exists on a balance sheet and generates returns. It works like any other piece of infrastructure.
And now contrast that. Take that same $100 million and send it to Mars.
You send a rover, a habitat, a science experiment, it lands, and then what? Who is the customer?
Well, a customer is humanity, science.
And that's a noble cause. But humanity and science don't pay subscription fees. Maybe a government grant covers the initial cost, or a TV network pays for the rights to the footage. But fundamentally, there is no customer on Mars. That money is gone. The asset is static. It produces knowledge, which is valuable, but not cash flow.
So the source calls Mars a sunk cost mausoleum.
A sunk cost mausoleum. It is such a heavy, brutal phrase. It implies that we are building these magnificent, expensive monuments to our own ambition and curiosity, but they are tombs for capital. They're not engines of a new economy.
And it's not saying we shouldn't do it at all. It just frames it as what? Philanthropy. A public good.
Exactly. The author isn't saying we shouldn't ever go to Mars, but they're saying we need to be honest about why we're going. It's philanthropy, or it's philosophy, or national prestige. It's not business. LEO is business, and right now that's where the action is.
And that business is absolutely booming. The source lists what it calls the invisible infrastructure up there, and it's so much more than what I think people realize. We all know about broadband. Starlink is the obvious one, connecting rural areas, airplanes, ships.
That's the one everyone sees.
But it mentions PNT. We touched on it.
Yeah.
Precision navigation and timing.
Right. And most people hear that and just think GPS.
Yeah, for your phone, for Google Maps, for your Uber.
But it's so much deeper than that. The source highlights that the entire global financial system relies on PNT. The timestamps on stock trades, which have to be accurate to the nanosecond to prevent fraud and ensure fairness. That timing signal comes from space.
I had no idea. I assumed that was, I don't know, an atomic clock in a basement in New York.
There are clocks on the ground, but they all have to be synchronized with each other globally. The only way to do that with the necessary precision is to use the timing signals from GPS or other PNT satellites as a master clock. And it's not just finance. The synchronization of national power grids. That comes from space.
Wait, our power grid is synced from space. How does that work?
To manage the flow of alternating current electricity across a continent-spanning grid, you need incredibly precise timing to keep the 60 hertz cycle, the phase, perfectly aligned everywhere. If the timing slips by even a tiny fraction of a second between two regions, you get surges, you get brownouts, you get catastrophic blowouts. That master timing signal comes from satellites.
So if Leo goes dark, the lights literally go out.
The lights go out, the stock market freezes, your cell phone network collapses because the towers need timing signals to hand off calls, and shipping containers get lost in the middle of the ocean. It is the invisible utility that runs the modern world.
And that's just PNT. The source also lists Earth observation, low-latency connectivity for autonomous cars and drones. It's already woven into everything.
It is. So the source says we need to stop calling this space exploration. That's the wrong vocabulary. It's space industrialization. We aren't exploring the ocean anymore. We're laying fiber optic cables across it and building bridges over it.
That is a fundamental shift in mindset. And speaking of building bridges, or maybe burning them, we need to talk about who is doing the building. Because for the last decade, the headline has been SpaceX. It's been a very American show.
It has. They've dominated the conversation, and for good reason.
But the source explicitly pivots here. It says the most interesting momentum is shifting to Asia, specifically a head-to-head contrast between India and China. And I found this section fascinating because they seem to be playing two completely different sports up there.
They really are. The source calls them the new gravity wells in orbit, which is a great phrase. Let's start with India, because I think their strategy is widely misunderstood. The headline the author uses is Frugal Engineering Meets Orbital Ambition.
India's always had that reputation, right?
Mm-hmm.
The frugal engineering part. I remember the Mongolian mission, their Mars orbiter. Didn't that cost less than the budget of the movie Gravity?
It did, famously so. And for a long time, people in the West looked at India's space program, ISRO, as this scrappy budget underdog. Very impressive, but not a real competitor. But the source argues that something structural has changed in the last few years. It's not just about being cheap anymore, it's about being smart.
What's changed?
It's a potent mix. You have government reforms that have opened up the space sector to private companies. You have a flood of private capital, both domestic and international, flowing into these new startups. And you have this incredibly deep bench of technical talent coming out of ISRO and the Indian Institutes of Technology.
And the strategy isn't just to copy what others are doing. The source calls it space as commercial utility.
Right. It's a very pragmatic approach. Unlike the U.S. with the Apollo-era prestige or China's focus on national power, India seems to be less obsessed with space supremacy or prestige in the same way. They aren't trying to land a man on the moon just to plant a flag and take a photo. They are building tools. They're building services that have a clear business case on day one.
And the source lists a few of these startups that I think most of our listeners, myself included, won't have heard of. But they are apparently absolutely critical to this new ecosystem.
Yes, and they're worth knowing. Let's go through them. The first one mentioned is Viamas.
Viamas.
This is a perfect example of that utility mindset. They are building a private, commercial, LEO-based PNT system.
Okay, so again, navigation and timing. But why do we need a private one? We have GPS, which is American. There's Galileo in Europe, GLONASS from Russia, Beidou from China. The sky is full of them.
We do. But all of those are government-run, military-first systems. And as we've seen in Ukraine and other recent conflicts, GPS is surprisingly vulnerable. It can be jammed over a wide area with relatively cheap equipment. It can be spoofed.
Spoofed? What does that mean exactly?
Spoofing is a type of electronic warfare where you feed a receiver a false signal, tricking it into thinking it's somewhere it isn't, or that it's a different time than it is. Imagine a fleet of autonomous drones thinking they're over the ocean when they're actually flying over a city. Or a ship in the South China Sea suddenly finding its navigation, telling it that it's in the middle of San Francisco. It's incredibly disruptive.
So Siamic is building a navigation layer that's harder to mess with.
Exactly. More resilient. It's designed from the ground up to be resistant to that kind of interference. It's about resilience for critical infrastructure. If the main government-run grid goes down or gets jammed in a conflict, you switch to the encrypted commercial backup. For a country like India, having that sovereign capability is strategically vital.
That's incredibly smart. It's not about replacing GPS, it's about adding a layer of security.
It is. And then you have a company called Link. The source notes that they're Y Combinator backed.
Which usually means they're onto something highly scalable and globally relevant. YC has a good track record.
Link is building the internet for spacecraft.
Which sounds a little redundant. Don't spacecraft already connect to the internet to talk to us?
Not really, not in the way you think. Right now, most satellites operate in a silo. They talk to the ground, they fly over a ground station, dump their data, get their new commands, and then they're on their own again until the next pass. It's a store and forward model. Very inefficient.
So what's a People Link doing?
They're building the connectivity between the satellites, a mesh network in orbit using laser links. So if satellite A, an imaging satellite, sees something important like the start of a wildfire, it doesn't have to wait 45 minutes to fly over a ground station in Australia. It can instantly beam that data via laser to satellite B, which might be a communications satellite already in contact with the ground over California.
So it creates a real-time network in orbit. It turns individual satellites into a single, cohesive sensor web.
Exactly. It's the Wi-Fi for the machines. It reduces latency from hours to seconds. The applications for disaster response, for military intelligence, for financial data are just enormous.
Okay, that makes sense. And then there's the observation side. The source groups a few companies together as the Earth Observation Consortium. It lists Pixel, PeerSight Space, Satcher, Druva Space, and it focuses on this one specific term, hyperspectral imaging.
This is one of my favorite emerging technologies. It's going to change so much on Earth.
Break it down for us.
Yeah.
Because I assume they aren't just taking really high-res photos for, Google Earth or something.
No, this is way beyond a normal photograph. A standard camera, or your own eye, sees light in 3 bands: red, green, and blue. That's it. A hyperspectral sensor is different. It slices the light it sees into hundreds of very narrow bands, stretching from the visible spectrum far into the infrared.
So what does that let you see that a normal camera can't?
It lets you see the chemistry of what you're looking at. It gives you a spectral signature, a chemical fingerprint for every pixel. So a normal camera looks at a cornfield and just says, it's green. A hyperspectral camera looks at that same cornfield and says, that specific section in the northwest corner has a nitrogen deficiency, or there is a fungal infection starting in the southeast corner that isn't visible to the naked eye yet, or the moisture content in the soil is 10% lower than it was yesterday.
Wow. So it's not just a picture, it's a full-on lab test, a diagnostic scan.
It's a diagnostic scan from 500 kilometers up. It's used for precision agriculture, as we just discussed. It's used for mining to find mineral deposits on the surface by their unique spectral signatures. It's used to monitor water quality by detecting pollutants. It's used for military purposes to distinguish between real tanks and decoys. And India is betting big on this because it's actionable, high-value data. It helps farmers, it helps miners, it helps governments. It's that utility focus again.
And the source also mentions they are attacking the final pieces of the puzzle. Launch costs with companies like Skyroot and Agnical, and beaming the internet directly from space with Astrom. It really feels like a very complete, vertically integrated ecosystem is being built from the ground up.
It is. It's a systems thinking approach. India's strategy isn't just to build one piece of the puzzle, it's to build the entire value chain. Their strategic goal seems to be, we will be the most efficient, cost-effective, and reliable service provider for the global space economy.
Now let's turn the telescope to China. The source paints a very, very different picture. If India is the agile, efficient, utility-focused startup nation, China is the industrial juggernaut.
Scale as strategy, that's the phrase the source uses. And it's perfect. China isn't trying to find a niche in the market. They are trying to be the market. They are playing a game of overwhelming scale and orbital real estate.
The numbers here are they're staggering. I had to read them a couple of times to make sure I wasn't misreading a zero.
You're talking about the Guang National Mega Constellation and the Kainfan, or a space sail constellation.
Guang is targeting roughly 13,000 satellites, and Kainfan is targeting another 14,000.
So that's 27,000 satellites just from 2 Chinese state-backed projects. For context, before Starlink started launching in earnest, there were only a couple of thousand active satellites in total from all countries in all of history.
So China is planning to launch more than 10 times the total number of satellites that existed just a decade ago. And these aren't just paper plans, are they?
No, they are launching. And just as important, the source highlights the manufacturing side of the equation with companies like Galaxy Space. Their entire mission is to slash satellite manufacturing costs down to commodity levels. They want to stamp out satellites on an assembly line the way they stamp out toaster ovens or iPhones. They're removing the bespoke, handcrafted element and replacing it with mass production.
And there's G-Space, which is backed by Geely, the car company.
That's a crucial integration to watch. Geely is a global automotive giant. They own Volvo, Polestar, Lotus. Imagine every car they sell anywhere in the world being a native node in a Chinese-owned satellite network, always connected, always reporting data, not just for navigation, but for vehicle health, for driver monitoring, for IoT services.
That brings us to the expert analysis in the source, which gets a little chilling, to be honest. It says China understands that controlling LEO isn't just about providing internet access to remote villages.
No, this is geopolitics by other means, that's the quote. Whoever controls the dominant LEO network controls the data flow of the world. They control the timing signals that financial markets depend on. They control the ultimate surveillance high ground.
It's the digital equivalent of controlling the world's sea lanes in the 19th century.
It is exactly that. It's the ultimate high ground. If you run the network that the world's logistics, finance, and communications rely on, you have immense leverage. You can throttle bandwidth to a rival nation. You can prioritize your own traffic. You can, in theory, see who is talking to whom and where data is flowing. It's a strategy for information dominance on a global scale.
So we have this intense high-speed industrial race happening just above our heads in Ilare, India, building the precise, efficient tools, China building the massive, all-encompassing networks, and the U.S., primarily through SpaceX, trying to stay ahead of everyone. And meanwhile,
the public's imagination and a lot of the media coverage is still dreaming of Mars.
right. Which brings us to Section 3 of the source, the Mars reality check, and specifically the tourism mirage. I feel like we need to be the bearers of bad news here for a lot of people.
I'm ready. Let's do it.
The narrative we've been sold, and let's be honest, Elon Musk is the best salesman of this century, is that Mars is the backup drive for humanity, that we'll go there, terraform it, and have a second Earth if something goes wrong here.
A planet B, a lifeboat.
But the source dissects the physical reality of this.
Yeah.
And it is not pretty. Let's start with the trip itself, the 6 to 9 month journey.
Radiation. That's the silent, inescapable killer. Once you leave Earth's magnetic field, which, by the way, protects us and all the satellites in LEO, you are in deep space. You're being constantly bombarded by galactic cosmic rays and solar flares. These are high-energy particles, heavy ions that shred DNA like microscopic bullets.
And there's no real shielding against them, is there? Not on a spaceship.
Not effectively. You'd need meters of lead or water to block the most energetic particles. A spaceship can't carry that much weight. The fuel requirements would be impossible. So every astronaut who makes that journey will absorb a massive dose of radiation, significantly increasing their lifetime cancer risk. We are well beyond accepted safety thresholds for astronauts on the ISS.
Okay, but you land. You made it through the radiation bath. You pop the champagne.
You pop the champagne inside a heavily shielded habitat because outside there is effectively no atmosphere. It's about 1% of Earth's, and Mars has no global magnetic field. So the radiation on the surface is still lethal over the long term. You aren't going to be walking around in a glass dome looking at the view.
You're living underground.
You're living in a cave. A lava tube, or a buried bunker, dug under several meters of Martian soil, the regolith, to protect you. The source calls it prolonged confinement under lethal conditions. It's not a frontier adventure, it's a survival scenario.
And what about the weather? We see these beautiful pictures from the rovers. Looks a bit like Arizona.
It's a lot more hostile than Arizona. The dust storms, we're not talking about a windy day. We're talking about global dust storms that can block out the sun across the entire planet for months at a time. If you rely on solar power, which is the most likely energy source, you're in serious trouble. And the temperature swings are violent, from maybe room temperature at your feet at noon on the equator to minus 100 degrees Celsius at night.
But the thing that really stuck with me in the source was the gravity issue. It's not 0G, but it's not Earth gravity either. Mars has about 38% of Earth's gravity.
Just over 13G. And this is a huge unanswered question. We know from decades of research on the space station that zero gravity destroys the human body. It causes bone density loss, muscle atrophy, vision problems, heart issues. We assume 13 gravity is better, but we actually don't know if it's enough for long-term health.
Can a human fetus even develop properly in 13 gravity? Can a child grow up to have strong bones and a healthy cardiovascular system?
You have no idea. It is a massive multi-generational biological gamble. And then there's the isolation factor, which might be the cruelest part. The source makes this chilling comparison. Earth might as well be another galaxy.
Because of the communication delay.
The speed of light is a hard limit. Depending on the planet's positions, that delay is between 4 and 22 minutes. One way. So you say, hello, Houston. They hear it up to 22 minutes later. They say, hi back. You hear it 44 minutes after you first spoke. There is no conversation. There is no telemedicine with a doctor on Earth. If you have a heart attack or a ruptured appendix, you are on your own with whatever limited medical facilities you brought with you.
The source compares it to a research station in Antarctica, but even that doesn't quite capture it.
It's a great starting analogy. People go to Antarctica, they do science, it's hard, it's dangerous, and it's lonely. But if things go really wrong in the Antarctic summer, we can get a plane there in a day or two. And the air in Antarctica is breathable. And you can have a real-time phone call home. Mars is Antarctica without the air, without the rescue plane, and with radiation that gives you cancer.
So the verdict from the source is pretty clear.
The verdict is that Mars colonization, for now, is driven by curiosity and symbolism, not by economic or survival logic. It's a theatrical fantasy. A noble one, perhaps, but a fantasy nonetheless.
Which brings us full circle, back to the real economic engine. If Mars is the dream, SpaceX is the company selling the tickets. But the source argues we've profoundly misunderstood the SpaceX business model. We think it's about rockets.
And the rockets are amazing, but they are just the delivery trucks. Section 4 covers this, and it's a critical concept. SpaceX's LEO flywheel.
Explain the flywheel concept. I know Jeff Bezos famously uses it for Amazon, but how does it apply here to SpaceX?
A flywheel is a heavy wheel that takes a lot of energy to get moving. It's hard at first, but once it starts spinning, its own momentum helps keep it going, and it becomes easier and easier to spin it faster. For SpaceX, the flywheel has 3 main parts. Part 1, launch dominance.
The Falcon 9, and in the future, Starship, reusability.
Right. They have utterly collapsed the cost to get a kilogram into orbit. This is the enabler. This is the first big push on the flywheel. By making launch cheap and routine, they unlock the second part of the wheel, global connectivity.
Starlink. The mega constellation.
Starlink is the cash generator. It's the recurring revenue business. It brings in billions of dollars from millions of subscribers. That reliable cash flow then gets reinvested into making even bigger and cheaper rockets, which spins the first part of the wheel faster. But here's where the source adds a new third component that I think is the most important insight of the whole piece.
This is the XAI connection.
Yes. Usually people see XAI, Elon's AI company, as a completely separate venture, a competitor to OpenAI or Google DeepMind. But the source argues it is not separate. It is the third leg of the flywheel.
Launch, connectivity, AI. How do they connect? What's the synergy?
Think about the loop. Rockets launch satellites. Satellites generate massive amounts of data and provide global, low-latency connectivity. Who is the biggest consumer of data and connectivity on the planet? AI. Who needs massive, globally distributed compute and bandwidth to train and run their models? AI.
And as the AI gets smarter and more power-hungry, what does it demand?
More compute, more data, more energy.
Which requires more satellites.
Which requires more and bigger rockets to launch them.
It's a self-feeding, self-reinforcing organism. Each part of the business drives demand for the other parts.
Exactly. The source calls it the dissolution of the boundary between space infrastructure and digital infrastructure. XAI isn't just a software company running on Amazon's cloud. It's becoming the reason the SpaceX cloud exists in orbit in the first place. It's the killer app for the infrastructure.
And this leads us to what is, I think, the most sci-fi sounding part of the article, but the part that the engineer in me and the physicist in you knows is actually just about thermodynamics and economics. Section 5. Orbital AI and data centers.
This is the aha moment of the whole piece. This is where it all clicks.
The source starts by describing what it calls the terrestrial problem. Basically, AI is hitting a physical wall here on Earth.
It's a literal physical wall made of copper, silicon, and concrete. We treat the cloud like it's this magical, ethereal thing, but it's actually millions of tons of hardware in gigantic warehouses, and that hardware is incredibly hungry.
The source mentions that training a single frontier AI model, like a GPT-6 or whatever comes next, rivals the power usage of a small town for months on end.
It does, and all that electricity gets converted into one thing: heat. These data centers generate massive amounts of waste heat. You need rivers of fresh water to cool them. You need huge amounts of land, usually near a power source and a water source, and you need permission from the local community.
Regulatory patience, as the source cleverly calls it.
Right. Try to get a permit to build a new gigawatt-scale nuclear-powered data center in the suburbs of Virginia or California. People will sue you. The grid can't handle the load. We are literally running out of electricity, water, and land to feed our AI ambitions.
So the solution is to leave, to move the problem off-world.
It sounds crazy, but the physics are compelling. The orbital solution, the source calls it paradoxical abundance. On Earth, energy is scarce and expensive. In LEO,
You have the sun.
you have a giant 1.3 kilowatt per square meter nuclear fusion reactor that is always on. If you put your satellite in what's called a sun-synchronous orbit, it essentially never experiences night. It has constant, infinite, and effectively free solar power. Problem one, energy, is solved.
Okay, so you have the power. But what about the heat? Computers hate heat, and you just said the sun is always shining on them.
This is the beautiful, counterintuitive part. Space is filled with sunlight, but the vacuum itself, it's a perfect heat sink. It's nearly absolute zero. On Earth, we use air or water to absorb heat and carry it away. It's inefficient. In space, you can just use radiators to beam the waste heat out into the void as infrared radiation. No water needed, no cooling towers. Problem two, cooling is solved.
So you have infinite power and infinite cooling. And the third problem was land.
And in space, you have infinite real estate. You don't need a building permit in LEO. So, power, cooling, land. The three major constraints on Earth are abundant in orbit.
But I have to play skeptic here just for a second.
Yeah.
What about the latency? If I'm on my phone asking XAI a question, and the server is literally in space, isn't that going to be incredibly slow?
You'd think so. And for a server in your city, yes, the local one will be faster. But for connecting, say, New York and London or Singapore and Frankfurt, space actually has an advantage. And the reason, as the source points out, is something physics nerds love: the speed of light.
Isn't that a constant?
It is, but only in a vacuum. The speed of light in glass and the fiber optic cables that make up the internet's backbone is about 30–40% slower than the speed of light in a vacuum.
Really? I did not know that. I thought it was all the same.
Nope. Light literally drags when it goes through fiber. So if you were sending a signal from New York to London through a 6,000-kilometer undersea cable, it's actually slower than beaming it up to a satellite, bouncing it across a vacuum mesh network with lasers, and beaming it back down to London. For global services, an orbital data center connected by laser links could actually be faster than a terrestrial one.
That is completely mind-blowing. Yeah. So the vision here, the AWS in orbit vision, is that we stop building these massive concrete server farms on Earth.
And we start launching server satellites, modular units. Essentially, rack-mounted servers in a box with solar panels and radiators. You launch 1,000 of them, they connect to the Starlink laser mesh, and they start crunching numbers for AI customers immediately.
And unlike a Mars colony, they make money from day one.
Exactly. The same people who subscribe to Starlink for bandwidth become customers for XAI's compute services. You are selling the compute. It completes the economic loop of the flywheel.
It makes so much logical sense when you lay it all out like that.
Yeah.
But it also sounds incredibly messy. I mean, we're talking about launching tens of thousands of new large objects into an already crowded space. Which brings us to Section 6 of the source, which deals with risks, governance, and the big picture.
We have to talk about the risks. This is the flip side of the utopia, because if this goes wrong, we could ruin nearer space for everyone for generations.
Top of the list has to be space debris.
The Kessler syndrome. It's the nightmare scenario.
That's the idea that one collision creates a cloud of shrapnel, which then causes more collisions, which creates more shrapnel, until there's a cascading chain reaction that creates a lethal cloud of millions of tiny bullets surrounding Earth, destroying everything in orbit.
Exactly. And if we have 13,000 Chinese satellites, 10,000 or more Starlinks, thousands of Indian utility sats, and now huge multi-ton orbital data centers, the traffic management problem is just insane. It's an order of magnitude harder than air traffic control.
And there's no global space traffic control authority, is there?
Not really. There are international treaties, but they are decades old and have no enforcement mechanism. There's no global policeman who can write a ticket for speeding or for flying too close or for creating debris. It's still the Wild West up there.
The source also mentions a couple of other risks I hadn't considered. Thermal density. If we have thousands of hot computer servers radiating heat, does that actually change the local environment of the upper atmosphere?
It's a valid question. We are dumping huge amounts of energy, as heat, into the thermosphere. We don't fully know the consequences of that on atmospheric chemistry or density. And then there's a spectrum coordination problem. Everyone is trying to scream over the same radio frequencies to talk to their satellites. It's getting crowded and noisy.
And then the geopolitics returns with a vengeance. The source calls this new orbital layer the global intelligence infrastructure. If the world's smartest AI lives on a server floating in orbit, who owns it? Who controls it?
If it's a U.S. company that owns it, does U.S. law apply to it at all times? What if it's physically orbiting over China when it makes a decision? What if it's over international waters or international vacuum? The source suggests we are entering a legal and ethical gray zone that is incredibly complex and dangerous.
Back to geopolitics by other means.
Exactly.
Okay.
If you can launch a cyber attack against your opponent's orbital AI, or blind their navigation satellites, or cut off their financial timing signals, you can cripple a modern nation without ever firing a shot on the ground. This is the new frontier of warfare.
It's both terrifying and, as you said earlier, it feels kind of inevitable.
The economic forces are just too strong to stop it. The thirst for compute, the need for connectivity, it's a force of nature at this point, and it's pushing us upwards.
The source ends on a more philosophical note that I found really profound. It tries to redefine what it is we are actually doing up there. It challenges that old colonization mindset.
Yes. And I think this is the key takeaway. It says, space is not a place to visit. Space is not a place to colonize. Space is a place to run systems.
Orbit is the extension of civilization's nervous system. I love that line.
That's the quote. And it's a perfect analogy. Think about a biological organism, a body. Your brain is in your head, protected, consuming a lot of energy. Your nerves run everywhere else, sensing and acting. Humanity is building its brain and its nervous system in the thin shell around the planet. Data flows up from the senses on Earth. Computation happens above, and intelligence flows back down.
It really changes how I look at the night sky. I used to look up and think about astronauts and distant stars. Now I look up and think about servers.
It's maybe a little less romantic, I'll grant you.
Yeah.
But it's much more functional and much more impactful on our daily lives.
It's the server room for planet Earth. The router, the eye in the sky, all in one.
All in one.
So to wrap this up, because my brain is officially full of new ideas, we've gone on quite a journey today. We started with the Age of Abundance prophecy.
Which it turns out was about data centers, not about manna from heaven.
We debunked the Mars mirage. Sorry to all the dreamers. It's a sunk-cost mausoleum.
For now, at least, the economics just aren't there.
We looked at the incredible geopolitical race between India's pragmatic utility model and China's overwhelming scale model. We unpacked the SpaceX flywheel and how AI is the secret ingredient. And we realized that the future of artificial intelligence is probably floating 500 kilometers above our heads.
It's a complete restructuring of the Earth-space relationship, from a place of exploration to a place of industrialization.
I want to leave our listeners with a final provocative thought from the source material. It asks a question that I think justifies this entire deep dive, and it's been rolling around in my head ever since I read it.
Read it out. It's a good one.
The source asks, if the world's most advanced computer ends up in space simply because that's where the room was, does that make us an interplanetary species, even if our physical bodies never leave the ground?
It's such a profound question. We've always defined interplanetary or spacefaring as boots on the ground, human bodies on other worlds. Maybe that's an old-fashioned 20th century definition. If our mind, our collective intelligence, our economy, our art, our logic, if that resides in space, have we already left the cradle?
Maybe we have. And maybe the Age of Abundance isn't about finding a new planet to exploit or escape to. Maybe it's about building a machine above this one that helps us manage it better.
A machine that solves our biggest constraints: energy, compute, and connectivity. I like that version of the future a lot more.
It's practical, it's industrial, and it's happening right now, whether we notice it or not.
It's happening overhead, every 90 minutes.
Thanks for joining us on the deep dive. Keep looking up and maybe wave at the data centers.
See you in orbit.